I'm Coach Kelly Honholtz with Revolt Power, and today we're going to be talking about safely working on battery modules that have compression bars. If you like the video, please do the whole like, subscribe, and share dance. We'd really appreciate it. It helps us keep bringing good information to you. So, what are compression bars and why are they important? As a battery charges and discharges, there's a small amount of heat generated. The faster the charging or discharging, the more heat that's generated. This translates into thermal energy. And as Einstein said, energy cannot be created or destroyed, it can only be changed from one form to another. So with this heat comes expansion and contraction, which is a form of mechanical energy. Battery developers use compression bars to manage this mechanical energy, and all batteries are subject to the phenomenon. Our batteries, especially batteries that are stacked in linear fashion, such as this is a CMAX Energy plug-in hybrid pack that we're going to be working on today. So why is working on it dangerous? The compression bars are these 4 pieces of stamped steel that you see at every corner that run the entire length. If I just removed the screws and pulled them off, the battery would kinetically disassemble itself. It would literally spring apart, tearing the cells up and possibly damaging them, and more importantly, possibly injuring you. So we have to manage these and work on them in a safe, effective manner. So that's what we're going to be doing today, and I'm going to show you one method. There's 2 that really work with this. One's a compression jig, which I don't have one here, and the other one's going to be using what we call a chain plier. So, do all batteries need compression bars? Cylindrical batteries, such as the 18650, tend to expand and contract linearly. They tend to elongate rather than get fatter. So, having plates on the top of them, that's why they have these huge plastic plates over the professional ones, is to basically manage that mechanical energy. But whenever we have battery packs that are basically lateral, or linear, you see that battery manufacturers have complete systems such as this CMAX one, usually comprised of metal. In this case, we have 4 stamped compression bars with aluminum end plates. And this is designed by engineers to combat a problem that is known. So I generally recommend, if people ask me all the time, I'm building my own battery system, do I need to do a compression bar system? And my general response is yes. I cannot count the number of failed DIY power walls that I have seen that had improperly or no compression system at all, that 6 months down the road, all of a sudden the owner is complaining that their homemade battery or power wall has failed. And generally I can look at it in the first minute and tell you why, and in a lot of cases it's due to a lack of a proper compression system. So, can you make your own compression system? Absolutely. The best ones are going to be, again, metal end plates, threaded all rod, the big heavy ones. I generally tell people that you want to use a 7/16 or bigger, which is about 10, maybe 11 millimeter. Have at least 4. Some people will do 2, but when you look at it, all of the engineers have always settled on at least 4. They want it to be really strong with a lot of even pressure. We don't want that plate to bow or bend either horizontally or vertically. So by having 4 points of contact, we can manage that from all sides. The end plate should be steel or aluminum. And we'll talk a little bit about the dissimilar metal issue with having steel that goes through into an aluminum body. We'll get into that in a minute. You can't go wrong going too strong, but you can go seriously wrong by going too weak. I see systems that are made out of recycled or repurposed cutting boards, plastic cutting boards, and that just doesn't cut it, to make a joke. We really need to have something that was designed or is capable of withstanding the mechanical energy we're going to be producing as we charge and discharge this. So anyway, what are we going to need today? We're going to need some safety gear, some gloves, some eye protection, some compressed air, either anti-seize or dielectric grease. Either one works fine. We need about a half a dozen little rubber caps. We need our chain pliers, which is the tool that I spoke about a minute ago. These are available on Amazon. They're about $25. You need a really long one. This one, I believe, is 36 inches. Yeah, 36 inches, about 1 meter long. You're going to need an appropriate Torx to remove the screws. And in this case, we're going to be removing the screws to put studs in. So we need an appropriate socket for the studs. We need also a shop towel. Usually one of these microfibers is really clean, or really good for wiping up any messes or dust and dirt. And we need one clean shop towel. And they both need to be dry. We don't want anything that's moist or going to be conductive here. So before we start, we're going to do a couple things. First of all, we're going to get our gloves on. These are not anything. These are nitrile layered gloves from Walmart. I think I spent $2 on them. Put them on so that they're nice. They give me good dexterity. I can pick up little stuff like those rubber caps pretty easily. Get those on. There we go. And these are a little bit, I've got boxes of those nitrile and latex gloves. These are just much more durable. Now, I need to get this up off the ground, or off the bench surface. So what I'm going to do is I've got a piece of signpost here. I'm going to set it here. These are not terribly heavy, but all we're going to do is pick it up and set it on the end. Once we got it up a little bit, we can slide this back. We want it back away from these corners. Okay, we've done that. So now we can start getting ready to actually work on the battery. We're going to take our little rubber caps and we're going to put them on the first 3 posts. Helps if I don't put them on upside down, on each side. In case something were to slip, or because we're going to be working primarily in this area here about a hand width from the end. If something were to slip, we don't want to contact any battery posts and cause a problem. Once we've done that, we're going to take our clean shop towel. This one's cotton. We're just going to lay it in there to provide another layer of safety over those battery posts. That's all there is to it to getting prepped and set up. Once we've done that, we're going to take our chain. These things are really, really hard. If you don't work with them all the time, they can be kind of a pain. They're kind of like untangling a chainsaw. You just hang them up until you get to the point. Now, once you've done that, you're going to basically hold it so that the hook is facing towards you. You're going to very carefully, so we're not contacting anything, wrap it around. You'll see it's got a little notch there. And what you're going to basically do is get it till it's pretty tight. And we need to get it right next to the end if at all possible. Not more than about a ½ inch, or call it 6 or 7 millimeters away from the end. Okay. Trying to catch one more tooth, but I don't think I'm going to get it. So once we do this, we start to bring this together. We should be pretty tight. We can start to adjust. Let me move this up just a little bit. We can start to tighten these chain pliers by turning down on this. And you'll notice I've got the tip of the chain plier right here at the corner on the steel so that it can't contact the battery or the battery post. And once it's nice and tight and it can't move, you can tighten it down. You ain't got to tighten it till it cracks, but tighten it down so it's nice and tight and it can't move. And it's no more, it's a little bit further back on this corner than I like. I'm going to move that a little bit closer forward. There we go. Now it's nice and even, equal distance all the way around. And why am I going through all this, you might ask? Well, this is a battery for a client that I'm building. And what this is going to need, this is actually the back end of the top module. They'll be stacked up 4. And what I need to do is this plate here will actually hold the relay assembly, or excuse me, the breaker assembly on it. So it's easily accessible. Well, the problem is I can't just take these screws out, because if I do that, the battery's compression will bend this end plate, pop these compression bars off, and then the battery will spring apart. So by putting the chain pliers on here, I'm holding these compression bars in place so that I can work on them. Now you'll notice that there's a little aluminum boss that sticks out about a quarter inch, about 4 millimeters on each side. So I can't just go back with screws, because then I'd have a gap between the back of this and the end plate here. So by converting this to studs, the studs already have a little shoulder that's going to sit off, and it's going to clamp the compression bar nice and tight against the end plate, and it's also going to move my mounting plate out a little bit so that I don't have to worry about there not being enough force to hold either the mounting plate or to hold the compression bars in place. So once I've got that, I'm going to grab my wrench, just going to very gently take this off. Now if you start to remove it and the screw starts to drag or doesn't want to come out, generally that's a sign that the compression bar is trying to move. So you need to stop, don't take the screw all the way out, put it back in, check and see why it's slipping or why it's moving. In this case I know it's secure, so I'm going to go ahead and take this screw all the way out. Once I've got it out, I'm going to put a little dab of dielectric grease. I actually got a little bit too much there, so I'll put some of it on this one too. And what this does is that because I'm running a steel screw into the aluminum body, it prevents the steel from galling and seizing into this aluminum, so that if I ever need to work on it again, it's simply a matter of unscrewing it. You don't have to worry about the screw breaking off or it not coming out properly. So I just tighten it up finger tight. And once I got that, come over here to this side. I'm going to move my canned air over a little bit, and I'm going to go ahead and break this one free. That one's a little bit easier. Now you should also note that when you're screwing your stud or whatever accessory into it, if you feel that dragging, again, there may be something wrong. Stop, check your work. So again, I'm just going to take my stud. You should be able to completely tighten by hand. Now Ford doesn't publish on this particular module the torque specs for this, so I generally use the tighten it and then a third turn. So I'm going to go ahead and get it on there until it's snug, and then I'm going to go a third of a turn more. Snug. Third of a turn more. There we go. Okay. Awesome. Get the cap back on our dielectric grease so we don't squirt that everywhere. Now it's simply a matter, keep your screws, you never know when you're going to need them. I got a can over there just for that. All we've got to do at this point, real quick while I've got it, this is the plate that I'm going to be mounting. You'll see that it's already slotted. I've got to finish painting it and smoothing out the edges. But I can also do a test fit right now. Make sure that it's the correct dimensions. It fits exactly between my side mounting bars. And I note this is already correct because I did test fit it earlier on another battery. So I note that's correct. I'm going to set my tools aside. At this point, I just unscrew my chain pliers. Very carefully pick up this end. And all we got to do is once we get it there, be real careful. Maybe loosen it up a little bit more. Like I said, they're kind of tough to work with. They're designed for going around a round piece of pipe. Take it off, kind of fold it for storage, and put it back where it goes. That way it'll be easier to find it later. Now at this point, all we've got to do is take off our rag, shop cloth, excuse me, pull our caps off. Eventually when we get all of our bus bars in here, each post will have its own individual cap at that point in time, but right now we're not at that stage. We're just doing our test fits and getting everything ready. So now you understand a little bit about why compression bars are necessary, why they're important, and why you have to treat them with care. So if you have any questions, feel free to ask me in the comments. Again, we would ask that you like, subscribe, and share. And we're going to be doing a lot more videos like this where we're discussing issues of this potential type. And we'll see you then.